Finding the composition of an unknown hydrate. We have here an electronic balance, a Bunsen burner, a ring stand with a ring, a clay triangle. We have our unknown hydrate, wire gauze, crucible with cap, tongs, and a measuring scoop. First things first, put on goggles and apron. Find the mass of the crucible.
We must put some of our sample into the crucible. And we will weigh that with our electronic balance. Its mass is 40.277 grams. After lighting the Bunsen burner, we must place it under the ring stand and under the clay triangle. Now we pick up the crucible with the tongs and place it easily on the clay triangle.
Can you turn the voice down? Can you turn the sound?
Now, you don't
Since bubbling has stopped, now we must heat it under a strong flame for 5 minutes. After 5 minutes, we remove the crucible from the flame carefully with the tongs and place it on the wire gauze, where it will cool for 10 minutes. After cooling for 10 minutes, we must carefully use the tongs to place the crucible and the sample into the electronic balance. And we must take its mass at 39.391 grams.
To start, we are going to calculate the mass of the sample before it is heated. We are going to do this by subtracting the mass of the empty crucible and lid from the mass of the crucible and lid with the sample inside. Now we are going to calculate the mass of the sample after it has been heated. To do this, we will subtract the mass of the crucible empty from the mass of the crucible with lid and sample after heat.
Why do I want this open freaking Google Drive?
Since in heating the water is lost, we are going to subtract the mass of the sample after heating from the sample that was not heated to find the amount of water that has exited the system. So now we are going to convert the grams of water lost into the number of moles of water lost. To do this, we will divide the grams of water by the molar mass of water, which is 18.02 grams per mole. Now we're going to calculate the moles of calcium nitrate that were present in the solution. To do this, we are going to divide the grams of the sample after heat by the molar mass of CaNO32, which is 164.1 grams per mole.
Increased amount of salt that are in your muscle region, which forces the contraction of your muscles, and so all it does is make contraction. That's why also if you have a
So the mass of the empty feature
have you ever had Charlie horses where you won't in the middle of the night your cat is killing you because it's all stuck? It's because now there's an influx of those sodium or
Now to calculate the formula, we divide by the lowest number of moles, which in this case is calcium nitrate.
from my classes, did wasn't it?
This will give us the fraction of each component.
And that's about 25. So I'm gonna weigh that. Comes out to 91.11 pounds. So
Anything should be done like the about 81.
Knowing these numbers, we can deduce that the formula of our calcium nitrate hydrate is CaNO32 times 3H2O.
So here we have the results of our experiment where we calculated the empirical formula. Let's discuss some of the error that could have occurred during this experiment.
So some of the errors that might have occurred are inaccuracy in heating, meaning we either heated it too much and some of the gas might have escaped, or we didn't heat it enough and we didn't get rid of all the water in the sample.
Another possible error could be if we heated it too strongly at first, some of the sample could have escaped with the water. Some other error could have occurred with the cooling process.
So we might not have let it adequately cool for a long enough time, which would impact our weight measurements after the sample had been heated. Also, when we were heating the sample, we didn't leave the lid ajar, meaning that some of the water that became dissociated with the hydrate could have just recycled back into here and never actually burned off.